Here we have AP calculus AB problem. Okay, let's go to the question. Find dy over dx if y equals to cotangent of 6x negative 3. Okay, here cotangent of 6x negative 3. At the place of 6x negative 3, if I have single variable, I can find its derivative easily. So that is, let me write the derivative of cotangent of x. So the derivative of cotangent of x is equal to negative cosecant square x. So here we just have x, but at the place of x we have an expression over here. So how do you have to get derivative for this function? So for that we have to use a chain rule. So to use chain rule, first let me assign a new variable. So at the place of 6x negative 3, because the troubling part in this function is 6x negative 3. At this place I just need single variable. So that I'm going to assign a new variable for this expression 6x negative 3. So that is let u equals to 6x negative 3. So then the given function becomes y equals to cotangent of u. And we know that u is a function of x, that is u equals to 6x negative 3. So y is a function of u and u is a function of x. But according to the question, we have to find dy over dx. So let me write that stuff over here, dy over dx. Okay, can I find derivative of this function with respect to x? No, it's not possible because y is not a function of x, y is a function of u. So we can find derivative of this y with respect to u because y is a function of u. That is dy over du. Further, u is a function of x. So I can find derivative of this u with respect to x, that is du over dx. So this is called chain rule in finding derivative. So when I have some trouble to get derivative of the given function as it is. Okay, now dy over dx equals to d. Okay, for this y, we can plug in this stuff cotangent u. So derivative of cotangent u with respect to u times derivative of, for this u, we can plug in this stuff for 6x negative 3. Let me do it over dx. Let me continue the stuff for here. Dy over dx equals to, okay, now we have to get the derivative of cotangent u with respect to u. So already we have discussed the derivative of cotangent x with respect to x, that is negative cosecant square x. Then the derivative of cotangent u is negative cosecant square u times the derivative of 6x negative 3 with respect to x is what? So here let's find the derivative of this 6x. So here the variable x is multiplied by the constant 6. Whenever I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is and I have to get the derivative of the variable alone. So when I find the derivative of this x with respect to x, it will just become 1 negative. The derivative of this constant 3 is 0. So now negative cosecant square. And this u can be replaced by the original stuff. Actually, this variable u was taken by us. It has to be replaced by the original stuff, that is 6x negative 3. So this is a stuff which is equivalent to u. So we can plug in 6x negative 3 for u. 6x negative 3 times. So let's do the simplification of this stuff. So 6 times 1 is 6. 6 minus 0 is just 6. So finally, dy over dx equals to, we can write this 6 in front of everything. That is negative 6 times cosecant square 6x negative 3. So this is the derivative of the given function.